then we go to TV. Share my screen. Okay. So from the last week's session, I know we have quite a bit of learning, a lot of concepts we have explored, and we did some hands-on as well. Anything you guys explored after that, after Thursday, the last 3 days over the weekend? Or at least reviewed?
Actually, no, Arun. Yeah, I just went to that one, not explored much.
Okay, that's fine. Yeah, we can do that this week once we do that. So what I'm doing here is I want to do the same RAG application. Let me see if we have to build it. 1 second. Pull up. We need to have the RAG thing here. Okay. Yeah, so we all have seen that same RAG application last week. We have done using Databricks platform. Okay, so the vector database was the native Databricks vector index, which is Databricks Delta. You can directly create index on top of it and use it as a vector search. So that is provided by Databricks. So we didn't have to use external vector database like FileDB or Pinecone or Chroma or whatever. And then we also looked at what Databricks has provided, creating all of this entire pipeline as a model, and then exposing it as an API. And the same API, once it is deployed or served as a model, then we could interact with that API from the external world if we had the keys to connect to the API. So that's what we kind of looked at in the last week use case. So the same RAG, now what we are trying to do is using Google Colab. The first part of it we already did up to the vector database, embeddings, and relevant data. So just getting the relevant data and question to the LLM and then getting the response is what the second part of the RAG application that we were trying to build. No, so there are several platforms to build the RAG application, as I said, one of which was the Databricks platform that we explored last week. Another is you can just write a Python script, this is all code, right? And end-to-end code, just like we did the creating vector database and querying the vector database for results, the same code thing, we can extend that again as a Python code to create the entire RAG application. And then you can use, as you put it in the production or deploy it as an application, Python application, and then put a serving endpoint and do all of that separately. And then you have a Streamlit. You can put a Streamlit app and build Streamlit app on top of this and then do that. Third is you have platforms like low code and no code platforms, like example, like the Amazon Bedrock or the DataStax Langflow. There are several others that we have, Llama Index. So where we can explore these orchestration tools to build these kind of RAG applications or agentic AIs. So if any of you have ETL or the exposure which says like, the UI based application, just like say Informatica, it will be similar thing. You drag and drop all the components. The same thing now we can do for the GenAI applications as well, GenAI pipelines as well. where you can drag and drop the components using Bedrock or using data stacks. So what are the components? You can say pretty much each of these boxes or items here, blocks, can be a component. So basically, platforms give you something like for query, something they give you input. For response, they give you an output object where you can drag and drop. And then you can connect input to a agent or something which can where you can configure the embedding and model. There you can configure what is the vector database you want to use. And then in that same block, you have parameters. You can give some like what you're giving in the Python, you can give the same keys in the configuration. So it will automatically connect. And then you can just put connectors, from where the data is flowing from which component to which component. So that is the low code or no code kind of platforms that we will explore this week. And after that, as I said, the entire thing will be same. Instead of just one LLM, you will have multiple agents. So there will be an agent which the LLM would decide, and the tools, the tools the agent can use to solve a particular problem. So those components will be added in this space, and that will become your agentic AI. So that will be our last session before we wrap up, and then we have some hands-on and wrap up. Okay, so what I'm trying to do, replicate all of this again in the Python, application, Python script, basically, so that it is easy. Okay, are you guys following? I will, I hope I'll get access to all of these notebooks. If you already don't have it, I have asked Ishrat to provide access to that folder, the Google Drive, where I have put all of these Python scripts, okay, notebooks. Now, if we go here, so same thing. So I'm pretty sure some of these may not be required, but I was trying to put in all of the things and see. So I will later filter this and see, remove what all is not required and keep what is minimum needed, but no harm. If we are importing a few more libraries, there's no harm as of now. All we want is to run and see how the RAG application works. So what I'm trying to do here is I'm using FireDB. We know we have already done FireDB here to use it as a vector database, right? So when you use FireDB as vector database, what we have done, we have uploaded a document, and then remember, uploaded my resume PDF. Then we used a chunking, all of that, and then put it in vector database. And then we used a retriever to query using the same embedding model. So that was a default embedding model, whatever FireDB has, that we are using. The same FireDB we are using for vector search. And for LLM, we are using GPT-4, OpenAI GPT-4 model that we will be using for the LLM part. So you know which is the LLM part here. So this LLM will be GPT-4, and this vector database will be FireDB, and this embedding will be default whatever FireDB already has that it is using. We can check. I think last time also we checked, it was showing somewhere. I don't remember if we have that output here. Chief token. Yeah, I don't think we have it here. Let's see. But yeah, we can see if it is visible somewhere. Last time we checked. So it's the default some Hugging Face, in the Hugging Face, whatever default embedding model that it has, it is using. We looked at it last time. So if we'll look at it later, but that's not a big deal right now. So the point is, we are using FireDB as a vector search and GPT-4 as our LLM model. So we first go and install all the required libraries. Okay, LangChain, OpenAI, Fires GPU for FireDB, CPU, and only one of these is required. and unstructured tick token. So there is a duplicate here. I don't need tick token here. It's already installed here. Pandas, NumPy, PyPDF, LangChain community. So all of this. So once you have these libraries installed, okay, now I'm going to import what I need from these libraries. OpenAI embeddings to do the embedding for the document. Docstore dot. So these are all standard pandas document, user data for the keys, files for the files DB, PDF by PDF loader, text loader, character splitter, LangChain, OpenAI embeddings, vector stores as files. Okay, so all of these, I know, as I said, there are some duplicates I need to figure out and remove some of them, but don't worry about the libraries and the import statements. If you have one too many, that should be fine, as long as they don't conflict with each other, and throw an error, you are good if they are not throwing any errors. Okay, so install the libraries, and then we need open API, OpenAI API key. So remember we did here. So I have enabled notebook access to Open API key. I don't need Pinecone because I'm not using Pinecone here. So I can just say enable this one, and I have the Open API key here. And then I have to upload the file. So this is the file path. So if I run it, it will say that file is not found, because normally once the session is ended, it will remove all the files that you have uploaded. So once this is done, we will upload that. Okay, so we are setting the Open API key. Why are we setting the Open API key? Anybody? Hema? Why we need Open API key here?
To expose it as an API, to consume it as an on the endpoint.
Yeah, why are we consuming that? Where are we using it? Open API.
I didn't.
Okay, so we are using it as an embedding model.
Okay.
OpenAI embeddings.
Instead of the default. But you said just now we are using the default embeddings, right?
Yeah, last time we were here. If you pass the embedding model that you are using, it will use that same embedding model.
Okay.
So if you don't pass, there is another version where if it has a FastDB, it will automatically use that. But here we are using OpenAI embeddings. Since we are using OpenAI, so we have to use OpenAI key. Plus, you are also using the GPT-4 model. That is also OpenAI.
Okay.
Right? GPT-4. So that's why you need the OpenAI key.
From OpenAI, right?
Yes, from OpenAI.
Last time we used this embedding model, all MPNet based V2.
Base V2, yes.
Yeah. I thought we are going to use.
So no, I think, so what we are doing is, I think that's still the same. You're right. Basically, we are saying OpenAI embeddings, but we are not giving what is the model.
Yes.
Right? So we are just giving embeddings, OpenAI embeddings. It's still, we have not explicitly given which is the embedding model within the OpenAI it has to use. So it still uses the default one, whatever in the OpenAI embeddings. Maybe it's the same one that you just pinged on the chat, but it still needs the OpenAI key, either for this or connect to OpenAI here, or the model LLM model that we are using as the GPT-4. So now once we have, so this is successfully installed. Okay. Now we are, what the first part we are doing is we are reading the document PDF, loading it, split size, chunking 1000, overlap 0, text splitter, split documents, and then embeddings, OpenAI embeddings. So we have all the chunks that are split in the docs object. And then we are creating an embeddings, which is an OpenAI embedding. So this will internally use our OpenAI API key. Okay. So these are all the options. See here, text embedding EDA 002 model. Right? You can see that.
Confusing Arun again. So we are either we are using OpenAI embeddings by default, or we are using GPT-4 model, right? So
No, both.
both?
So OpenAI embedding, see here, we are using at two places, right? So embedding is used here and here.
Yeah, but both should be same, no?
Both the same.
Okay.
Both are same.
So is it default embedding, or are we selecting any model for embedding? That's the question.
So what we are passing is use an embedding model from OpenAI.
Okay.
Which embedding model we are not specifying.
FiasDB default model.
Yeah, whatever. Yeah, we can take OpenAI embeddings. Will give you a default one model that will give you embeddings. That if we will use it to create vector and write it to FiasDB.
Question is, last time we used default FiasDB embedding model, I think, by passing this
Right.
model name.
This one. Yeah. So here this is a different. So see, every time there are different ways of using the APIs, right? So different ways of using the models. So here we have explicitly we want this sentence transformer model to generate the embeddings.
And here we use OpenAI. That is because it is already available free for FiasDB, right?
Yes.
Okay. And now we are overriding this with our OpenAI model. Is it correct?
Yeah. So if we don't use OpenAI embeddings, we just use sentence transformer model. This is not OpenAI. This is sentence transformer on the Hugging Face, which is free. So you can just take this sentence transformer model and use it as embeddings in this. Okay, this is the Hugging Face model that you are using. From Hugging Face, all MPNet base V2, which is open source. You can use for embeddings. Now here I'm using OpenAI embeddings, not the Hugging Face open source one. So OpenAI embeddings, you need to have OpenAI API key. So if it is free or it is charged pay per model is a different thing. So I think there is some rate limit you can use for free or something like that. So when you use this OpenAI embeddings without explicitly giving a model, so it says there is some default text embedding ADA 002 that it uses. Okay, to generate the embeddings. Okay. So that embeddings we are passing to FiasDB to store these documents. So basically what from documents will do is take this document, pass it to embedding, which is an OpenAI embedding model, generate the embeddings, vectors, and then store that in the FiasDB. So all that is written in this, all that is done in this function. List of documents and embeddings model. Embedding function to use. Okay.
My question is, if we are using default embedding here above while writing it to FiasDB, why are we using another model or specific model below before sending it to LLM? Why can't we use the
Where
same?
is default? There is no default. Where is default? FiasDB default?
No. OpenAI embeddings. Default OpenAI.
Yeah, this is OpenAI embedding, yes.
And below LLM equal to chat OpenAI temporary.
So that's what I'm saying. You're getting confused. The top one is this one. Okay. The GPT-4 is this one.
Okay. Yeah, this is the enhancement, context providing, right?
Context. Okay. So this is the actual LLM. So this is what we did retrieving from vector database. This is the first part of the use case we did. We get some 3 or 4 relevant records from the vector database. Now we are saying we'll pass this query and this context to another LLM. So this is the GPT-4 we are using.
Okay, got it.
Okay, so these are two different models. So we are using two models here. The first one to generate the embeddings. Okay, and this will be used twice. Here to write the document data into vector database, and here pass the query into this embedding. So whenever you get the query, use the same embedding model to get the results. So this is one model, embedding model. And this is the standard LLM to process this data. So that is our GPT-4 model that we are using. So with the chat OpenAI object. Okay, is that clear? All right, is it clear? Can we move? Hema?
Yeah, I got it.
Okay. Okay, so I'm again using the same file that we have here, the resume. And then OpenAPI key is also there. So I will go ahead and run this after uploading the file here. So this is already now, writing to FastDB these documents. We can check what docs. So there is some data that, each the docs object has, which is written here from the vector store. So now at this point, we can go ahead and test what so records that are the retrieval we can do vector search and retrieval. But what we are doing right now is this retriever, this vector store we are using as a retriever and then passing the results to a chain, LLM chain. Okay. So to build that chain, so basically the chain says this. So this chain part. So this chain will take the query embedding, it will take the query and pass it here, and it will take the relevant context results using the retriever. It will go get the vector, get the results, and then pass that. So everything, all of this chain is what we are building using the LangChain chain. So that chain, first we want create LLM component. So LLM model is our chat OpenAI, which is GPT-4. Okay, so these are some fine tuning variables, not in scope for right now. We can dig deeper and talk about it in the full training when we have. This will give you some kind of tuning parameters for the model, how for the responses. So you got GPT-4 as a model, and we are creating some buffer memory so that if you keep just like ChatGPT, you are talking, right, sending messages to ChatGPT, it remembers your previous questions, previous answers, and you can continue the conversation. So it will have that context of your previous questions and answers. So that's where the buffer memory sits. And using that, now you build a conversation chain using conversational retrieval chain from LLM. So what we need to pass, we need to pass a LLM model. We need to pass a retriever. So the retriever will actually cover this entire part, all of this. Okay, the retriever will take query, convert embedding, go and search against vector database, get the results. So all of this is built into the retriever that we have given here. So vector store as retriever. So what is our vector store? Vector store is a FastDB. What does FastDB documents has? These documents and the embedding model. So what are these documents? Is our PDF file. So it's all the way you can trace it back to your source file. So that is your retriever from the vector database. So memory you have, you build the conversation buffer memory, chat history. Okay. So let's go ahead and build this LLM memory deprecation fine conversation chain. Okay. Now, so my RAG is completely built LangChain. Now we can test. So if I want to test, so I will just put in a random question. Who is the issuer of the information security policy? So it says the text provided does not specify the issuer of the information security policy. So which is basically you're sending the query question to the vector store, and the vector store we have only put the resume here, right? Now let's say I want to search for certifications.
It is still taking the above query only, right?
No, the query is different here. We just put certifications here.
Related to the information security, it is chaining. Information about certifications related to information security, it is chaining.
Yes. If we don't build the memory here, let's say we remove the memory and see. Memory here. Chat history.
Comma.
Take this none. Sync keys. Sync some input keys. Chat history. What is chat history?
I think it is taking it from the
Here, default, it is default, right? Okay. Just something. This is memory. Now here we should be able to pass none, right? Okay, let's see. So now you get the following certifications and badges from the resume. Okay. Now, basically, if you see the difference, right? Last time when you did, it does not throw random text from the document as number of results. So it has taken all of those answers and then it has generated a in a proper format, right? In a list format. So this is from the LLM. So when you pass the context and the question, so it gives you the exact in the format, in a readable format, in the English language format, the answer. The individual has the following certifications and badges. Now, so this is the enhancement that we did using the our RAG vector database. Now, what we put here is like text provided does not specify the issuer of the information security policy, which is not there in the vector database. So sometimes, so this is what I think is in the, so what you have put as a prompt, system prompt to answer only from the system prompt only from the vector database. Okay. So overall, basically, this is the simplest way of doing the lang chain. So chaining all of your components and doing the RAG. So last time, basically what we did more of the in the Databricks environment. We did the same thing, but we had a lot more components. But this is the simplest version. Not sure if this is still each sentence. So these are all FireDB. We didn't do 1 second. If we used Pinecone, right? If we did Pinecone or ChromaDB, which one we did? So I have two of them. Which one's which? So let's see this ChromaDB. What we did in this. No, it's also the same. So I think, yeah, we did with the Pinecone one. Okay. Now look at the output here. Certifications and badges. We asked the same question, certifications, to the retriever. So this is how the retriever gives you. Okay. It just throws all the data around. Okay. It's not just the only the certifications. It also gave whatever is related information to all of this. All these rows, right? So all the chunks, whatever chunks are related to that question, it gave all the related results. So this is not the final output that we want, right? So what we did, we enhanced this. We sent this entire output to a RAG, and then we sent the query as well. So that's what we did in the RAG here. So we sent the retriever, all the results in the retriever, and to the LLM, that query. So it is already included here. So in the conversation chain you built, you are passing the query. Okay. And then you are getting the result as an answer. So now if you look, it has gone through all of that information and then extracted exactly what is needed in a proper format, just like ChatGPT gives you, right? GPT-4 in a proper format. So this is the RAG solution that you build. Now you can also build a lot of guardrails, lot of prompt, system prompt, and all of that here. But this is the basic how you connect the components to a RAG application. Okay.
So this beautification is because of the model GPT that we used to
Yes.
retrieve the response, right? After
GPT-4. This is coming from the GPT-4 LLM. Just the retriever will throw you results like this. The raw data, whatever is like matching with the vector search, it will throw all those results here. the entire chunk data. So if you have 1,000 characters, it will give you 1,000 characters of chunk. If you have 5,000, it will give you 5,000 characters in the chunk. But out of that, it says, if you know, so what is the actual content? So whatever is the section, certifications and badges. So it knows it has to take only extract the information in this section. And it also knows where this section ends, right? So if you see here, so maybe it says here it ends because it's skills, tools, and technologies, which is different from this. So it is able to understand. So that's the language. That's the what you call intelligence of the model to understand. Hey, from here, this is a different thing. It talks about skills and other stuff. So it's not the Databricks certification thing. So now if we want to say, take this and try, maybe, I have not tried, but maybe we can go this, do this and run this again. Okay. So now it has, see, it doesn't give certifications. Now it gives skills as a separate. What are the skills? Tools and technologies. It has separated all of the tools and technologies based on the query and response to the LLM. Okay. So you can run these two together. I mean, actually, you can enhance this a little bit to see what actually the retriever is. You can add the retriever function here to see from the vector store what is the output just as the retriever from this. So we will try to enhance this and see if we can run the same. What is the retriever giving and what is the LLM giving from the output from the retriever, or taking this input from the retriever and sending out what it gives. Okay. I think I need to update a lot of vector search DBs that we have done this last week, this week. There's only 2 here. And models, all of them we are using. Yeah, some work on this. Okay. So that's the RAG.
So basically, so last time what we discussed, that was the basic and this is the RAG, right? So what is the main difference between these two? If you...
No, that's what I was trying to explain you, right? If you look at this picture, this is the RAG.
Yeah. Yes.
Last time we did up to number 3.
Yes.
Retrieval. Okay, only retrieval from the vector
Only
data,
retrieval.
the vector search.
Okay.
You take document, generate embedding, store in the vector. You take the query, generate embedding, search vector, and spit out the results. That is what we are doing here.
Okay.
Okay, using Pinecone vector D. Now, what does a RAG has in addition is this raw information, whatever the context that you give. Now in the RAG, we add number 4 and 5. Basically, yeah, number 4 and 5. So number 4, what it does is it takes this query, it takes this data from the vector database, results, whatever this is retriever is giving you, all those raw data and the question, and it will try to answer the question from within the information that this retriever is providing. It will go through that small bit of information that retriever is giving you, and it will go through it, understand, and answer the question from that source, from that input data as a response. So that is what we are doing here, response. So only the extra is these 2 components that we are adding as part of the RAG. So this is actually the complete RAG. We explored this first part separately, just with the vector databases, and now we connected that to the LLMs using a LangChain model. Okay.
Yeah.
Okay. Are we good?
Yes, yeah.
Okay. All right. Ramya, are we good? I don't know if she has connected to audio yet or not. Who else we have here? Yeah, Ramya is good. Nabi, I don't know how much Nabi you got
Yeah,
in
I just joined.
data.
Okay, in the last. Okay. You're
Oh,
integrating LLMs with the retrieval data, right? And
yes,
then the
yes.
response. Okay. Okay.
Yeah, 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 yes, exactly. For the same use case. Yeah, you can just check the recording. Well,
I'll check the recording. Yeah.
yeah. So that's all, part of what we do as part of our notebooks. In the Python notebooks. Collab, the simplest. So I didn't give you any IDs like uh, visual visual code or uh, any of the Python local or CLIs, installing Anaconda or whatever, all of that stuff. So simple online collab. Now we move from all the code, everything is code here, to platforms. So low code or no code. So as I said, we will explore couple of uh, low code, no code things. One is the data stacks, Langflow. Other is Amazon. So everybody, I guess, probably if you don't have, will come up with a document to get an ID. But I think it's straightforward. Just have a AWS um, account in the Amazon AWS, and then once you go there, oh my god, this is hard. Impossible. Oh. Oh, okay. That won't happen. So if you go here, there is something called Amazon Bedrock. Now, how you can normally, when you go to console home, you can search here and say Amazon Bedrock. You can go here. So this is the Amazon's AWS platform for all AI. I think last time also we looked at some of the models that are open. We tried to look at price. I forgot about it. I think one of you already have figured out where it shows price of using those models, right? Maybe you can share. I still have to look for that. But see, this is the platform from AWS to create your AI, GenAI pipelines or applications. So you have like playgrounds. Basically, playground is you can select a model here, chat model. You can select model, any of these models. Okay. Um, Text model, on demand, inference, apply, and then you can just type and do just like chat GPT. So this is just a playground to check how the model responds or gives you a gives answers response to you. And there are some parameters. As I said, we will explore this later. So you can change each of these and see how your response changes with the model and with the parameters. So this is the playground. So you can almost go and check, select any any model to play with and see. Okay, so open the playground. So you also have like image video playgrounds you can choose with. You can select a model, Titan image generator if you want, apply. Okay, action generate image. You can say lion with wings in the cloud and run. There are so many other image video models that are different from these, which are on the creative side, like Mid Journey is very famous. And then you have Sora for the video, Runway ML. So all of these are pretty popular for image, audio, video kind of a thing. See? So these are the images, like you can give a lion with the wings in the cloud. So it will generate the images based on your text. Cool. So now you can add, say, add the NYC background. Or skyline or backdrop, something like that you can try. Okay. So the same cloud, the wings, and then there's a New York City backdrop. Cool. Okay. Now, same thing, you have like builder tools here. So basically you go to flows. So this is where you build your pipelines. So you can go to flows and say edit in flow builder, create a new flow. So as I said, you will have all of these components. You can use a condition, iterator, collector, logic if you want to build agents and prompts, lambda functions, knowledge base, S3 retrieval, S3 storage. If you want to retrieve from S3, if you want to store to S3 for store, the files, knowledge base is basically like, you are, so just like drag and drop. Okay. You can give configure your knowledge base here. Whatever is the knowledge base, suppose you have 100 files in a S3 folder, or you want to upload data into the S3, just like the PDF file you are putting in the, in some temporary storage, right? So something like that, you can use your knowledge base here. And then you can say retrieval query, retrieval results, all of that you can connect. So if you go nodes, logic, you have prompts, flow output. Where is the flow input? So this is the flow input you have, which is like your query, where you want to do the query. And then this is the prompt. Okay. So in the prompt, what you give, your query will go in here, prompt, and then you have to select a model to answer your question. This is just the basic chat GPT thing. What we are doing here is, what I'm showing you here is not this. What is that? I don't know. I think we don't have it here. The first part of it, remember, just user asks a question and LLM will give you response. There is no embedding, no model, nothing. So that part. So what we do here is we use we can select a model in this prompt, Nova Micro. So it will give Nova Micro here. User input, if I give like this, so if I remove this, okay. So see here, you will not be able to connect. Okay. So now the connector is broken because there are no variables that are passing from here, from the flow input or coming into the prompt. So basically what you will do here, what are the variables? You can say user input. So now there is a connection that available, you can connect. So where is this coming from? You can connect to this. So the input, whatever query you give will come here, and then it will use the model completion. So we are using model completion. So this is the model Nova Micro that we are using. So you can also use any models from the AWS. So here again, just like we saw in the Amazon Bedrock. So what are the models that are available? You can choose any of this model to answer your questions. So that model you configure here in the prompt. So the input is taken from the flow input. We'll use this model and then the output is provided. So where is the output going? You can use another widget here, flow output, and then you can connect this output from here to the input. So it says expression data flow output node, and then you can just connect these two. So input, model, output. That's it. Okay, simple then. Now, if I save this, okay, and go here, chatbot. In flow builder. Okay. So here you can test it out, your model. Test flow. So this is your input. Okay. So if I type was Mona Lisa, run. So it shows flow output node, and then it gives you information. It's one of the most famous paintings in the world, artist period. So all of this is generated by this model, Nova, that we used. That's one of the models. So what are we doing here? The same Python code. Now we are using this platform, low code, no code, to create a GenAI or RAG application. Okay. So this is, I know we just have one LLM and input output thing, but it gives you all of these to basically connect and come up with the entire RAG pipeline. So that we will explore this week. So this is one of the services or the platform from the Bedrock. Okay. So it has Bedrock Studio knowledge bases. So knowledge bases is where you can create your knowledge base, just like your data store, where to look for the data to ingest into the retrieval and the LLM part. Okay, you can have a structured data store, you can have vector store, GenAI, Kendra GenAI index. So any of that you can go and directly create here. If you say create knowledge base with vector store. Okay, so this is the name. You can description, create a new use service role, data source. So you have to give a data source here, which means, let's say if you have all your files are already stored in Amazon S3 bucket in a folder, you can give that source. So basically you have to try and relate what you did in your Python notebook RAG, right? So same thing. So this we have manually uploaded one PDF file, right? So the same thing you will that will be all the files in the somewhere on the Amazon S3. it will automatically read that and create the vector store. Or you can use web crawler. Web crawler is, it extracts content from public web pages you are authorized to crawl. So if you want to create a tool which can scrape data from the public websites and then embed it and put it in your vector store, you can use a web crawler. Normally, say if you are using any of these, say, real estate, you are a real estate broker or agent, you want to know what are the prices of the houses, right? Or what are the listings. Now you have 4 or 5 websites like Zillow, or you have Redfin. So you want to get data from all of those and then put it in your own personal website or something like that to search and get a demand forecast, or which area is you're having prices, or where you can find homes that are cheaper, all that kind of stuff, for example. Or if you are a financial agent, you can get the latest foreign exchange, or if you are a forex, what are the latest forex currencies in different websites. You can go and scrape that data. Gold prices that are listed, you can scrape that data. Or stocks, you can go to some financial websites and scrape that data. So if you have access, again, so that you can create and store custom created data source directly, flexibility to ingest documents into your vector database directly. So you can have your own custom data store. If not Amazon S3, if your data is somewhere else, on a server or on a Windows server or somewhere else where it can connect to and pull the data, that also you can do. If you say custom, you can also do that. Third-party data sources you can get from Confluence. Remember, all the companies' data, basically the information, documents about all the projects, architecture, technology, the to-do, FAQs, all of this information is on the Confluence. Now, it is a nightmare to search for a particular thing. You have to go through and get some manual search. You can use scrape all of that data and put it here. You can get from Salesforce, you can get a SharePoint. So basically, there are a lot of options, but end of the day, what you want to do, a data source is your source of data which you can use. So you can create a data store, you can configure and then select embedding models. Okay. So if you go here, so what is the data source? This AWS account or any other AWS account. Okay, if it is any other, then you have to, or even if it is, you have to choose where is the S3, your S3 location, what are the buckets available. I don't know, there is one here. I don't know what this is. I can just try and choose that. And once you choose that bucket, so all the files in that bucket will be read, just like what you are reading in the PDF file here, right? So just like this PDF file from this path you are reading, the same path, it will be read from that S3 bucket. So what is S3 bucket? We will, you have to learn from the data engineering cloud. Most of you have already know what S3 is, and rest of them already are learning with the data engineering. So we will talk about it there. Data storage in Amazon, where you put AWS, where you put your files or data in the S3. Chunking strategy, again, same thing. You give here chunking strategy, 1000 overlap. So somewhere you have to give that as a configuration. Default 300 tokens. Okay. Then fixed size, hierarchical, semantic. There are different strategies that you can use. You want to do the chunking strategy. These are all some advanced settings, optional. If you go here, now comes your embedding model. Next step, right? So same thing as you need here, OpenAI embeddings that you are using to create vectors or create embeddings from these documents. Same thing here also, you will choose. So everything you are writing in code here, and you are doing it using UI here. Okay. Now, once you choose the embedding model, the next part is vector database, obvious, right? So where you want to store. Quick create a new vector store. So the Amazon will itself create a vector store for you here. Or if you have already created, you can choose. See here it says OpenSearch serverless, Amazon Aurora, Pinecone. If you have a Pinecone DB, you can connect it here. Amazon Aurora. You have MongoDB. MongoDB Atlas also allows you to store vector. Neptune Analytics, Redis, anything that supports. Okay. Postgres server, Neptune Analytics, and all of that. And then you go review and create. So it will automatically create that knowledge base. Now, where is, after doing all of this, if you go back here, so if you go here, when you are building something in the flow, you can use that as your knowledge base here. So if you use drag and drop knowledge base, if you go here, the whatever knowledge base you have created there, you can select here. It will appear here. So then you can use that and configure and connect to these components. Okay. This we will cover in detail in this week. Okay. Once we are comfortable with the platform and basics, what is Amazon flows and all of that. Okay. All right. Knowledge bases. So agents, basically, when we will also try to explore this. Guardrails you can add in any of the prompts. Inference and assessment is after you create the model, how you want to see the metrics, monitoring and performance kind of a thing, evaluations. Okay. Yeah, so that is about the Amazon Bedrock. You create your AWS account, create your IAM credentials, and then use as much as possible default and root user. And then you can open Amazon Bedrock and look through it. Okay. Any questions?
So how much it will charge this one, the Bedrock subscription?
Pricing, I'm not sure how much. It's all like service based, how much you use, right? It does not charge just for Amazon Bedrock. Amazon Bedrock, it's just like you have an free, login account, but you will be charged if you use any of the services. For example, if you are using a model, and then once you use the model, you are running that pipeline, the number of S3, right? So you are using S3 for storage. So that will have some charge that you can check in the S3. What are the charges for 1 GB, how much it will charge, for 100 GB, how much it will charge. So if you put 100 GB of data there, the charge will be based on that separately for the storage. And that is what you are using here for your building your pipeline. The next part is if you are doing the RAG. Now you are using embedding model. You are using vector database. You are using LLM model. So all of these, do you want to use open source free or you want to use pay-per-use tokens? So if you use pay-per-use token, based on how many questions you ask, how much data you send in, that is charged based on the model. So that is the other charge. Other than that, if Bedrock itself, if you want to expose it as an application API or a model, then probably Bedrock will also charge you something based on the usage. So there is no fixed charge like Bedrock is this much. So it's all based on each individual components you select and pricing for usage of all of that. Okay. If you carefully select all free models, open models, then the charge will be less. Maybe S3 also you get some free tier thing. So if you keep it below that, that also will not be charged. but you have to keep an eye on pricing, how much, it's charged. I don't know if it is charging anything for me. So you can go here, conductor. User guides, developer guides. So somewhere it will be, visible, maybe settings, I don't know. You have to go and check your usage and billing. AWS pricing calculator. These are all, I don't know, takes so many things to calculate. Not this one, not pricing calculator. Anyways, it will be there somewhere in the site. You just have to search for that. 2-month free trial. Your costs are based on the number of accounts you assign to your billing groups with a flat monthly rate per account. New customers are eligible for a 2-month 62-day free trial. Billing conductor. Settings. Account. Here, billing and payments. Zero. So I'm still not, I think I created this account when I was in Canada. So it still says Amazon Web Services Canada. Yeah, I'm yet to pay anything to them. I just started this now, exploring. So yeah, I still don't have any, but I didn't use it much other than the free time. But again, yeah, depends on what models you are using, how much you are using, all of that part. Okay.
Yeah.
Nice. Okay, so this is one platform. So other platform I wanted to showcase, that we will be exploring is Langflow. Okay, so DataStax Langflow. You can also create an account here, the DataStax Langflow. Obviously, you will get some free components that you can create. I think up to 5 components you can create. You can create a new flow. It will be similar to what we looked at Bedrock. So I will go through that. Again, the one we looked at AstraDB, right? So AstraDB is actually part of the same, what you call network or ecosystem, where it has default connectivity from the DataStax Langflow. So if you can create a new flow, you want to create a new flow, you can go vector store RAG, simple agent, basic prompt. You can do this. It will give you all of this. You can start configuring this part. Okay. Or so here, simple agent, it will get you all of this. Okay. And then you can start configuring this. So I think you can get up to 3 or I don't know, 5 flows that you can create in the basic model, free model. You can go here, go to blank flow. It'll give you a same kind of, what is that? You do lucid chart or any of those diagrams, you do architecture diagrams, right? It will be similar to this. So on the left side, you have basically all of your components. Inputs, as we have seen, it's a chat input where the user will type something in the chat. So that is your chat input component. Okay. Outputs, again, you can have a chat output where the end output will be coming out. Then you can do prompts. Same thing, create a prompt. Okay. And then it will take a template. Here you can type your system prompt, user prompt, and then use curly braces to introduce variables, just like we saw in the AWS. Okay. Then comes your data. Okay. So data, as I said, it can be file. You can add a file here, and then you can say upload a file from your local system, or you can give a path, file in this thing. It can be API request, a directory, SQL query that it can connect to databases, URL, webhook, all of these things available. Then comes your vector stores, right? So which vector DB you want to use? Astra DB Graph, Cassandra Graph, ChromaDB, ClickHouse, Couchbase, Elasticsearch, FizeDB, MongoDB Atlas, PG Vector, Pinecone, Redis, VV8, all of the your vector databases that you can use. So how do you use that? You drag and drop, and then you have to give the connection strings, the configuration basically. What is the server connection string? What is the table? What is the search query, ingestion data, embedding? So each thing will be different for a vector database. And if you see here, it says embedding. So you can connect an embedding model to this vector search. And then retriever results. Then you take this and connect to the next component. Just like you did in the RAG, you are doing in the UI here. So these are all the vector databases that are available. Take up prompts, data, vector stores, embeddings. So again, all of this you can use as your embedding models. Cohere embeddings, Azure OpenAI, Amazon Bedrock embeddings, Mixtral, NVIDIA, Olama, OpenAI embeddings that we have already used. So when you do this OpenAI embedding, see here, what it needs, OpenAI embedding key. So this is same as what you are sending this, right? OpenAI API key. So you have to use the same key here in the OpenAI embedding key. So you can, so if you go here, this is already defined. Okay. So these are all the keys that I have defined. So you can select one of these keys, and then you can see the model here, which model you want to use for embeddings. So 3 small, 3 large, ADA 002. Remember, these are all the OpenAI embedding models that were there. Text embedding ADA 002 is what is here, default, right? What is this? We looked at it. Text embedding 3. I don't know, every time it shows something else. But yeah, basically, so you can use as we gave right here, embedding models. Yeah. So when you do the OpenAI embedding here, so you can select which model from OpenAI you want to use. And then you can use the OpenAI key. So this embeddings, you can simply connect here. So this embeddings will go to this embedding, which means this vector database, whenever you want to write into this vector database, it will use this embedding model from here. Ingestion data will come whatever chunking and all you have done. So all the docs object, right? So here, this docs object will come as a ingestion data here. And it will use this embedding model to generate the embeddings and store in the states and retrieve, basically. So once you do that, for example, the vector stores, embeddings, then you have models. So basically, again, as I said, this part, right? This LLM model, what we are using here for that model, GPT-4, to answer the question in a user readable format, in a proper format, using the retrieved data and the query. So that, again, those models here, you can use all of these: Anthropic, Claude, Amazon Bedrock, Azure OpenAI, Cohere, Grok. Okay, so Hugging Face. So we go to Grok, and then Grok API key you can use, and then in the Grok you have all of these models. So Grok is, I think, the Elon Musk thing company from so from them, and then they have all of these models available: Llama 3, Gemma, all of this. So you can use any of these models as your LLM, and then you have to give the API key, just like you give the Open API key. You can give the Grok API key, and then you have to connect system message input. Probably the search results go here. No, it's not there. Somewhere else. Okay. So retriever goes. No, I think this information is not complete yet. So basically, you connect this to a retriever, and then retriever will send the output here to the model to answer. So in the processing, you will have parse data. So all of that, right? You have to parse the PDF, and then you have to split text, cut the text based on the chunk size. So all of that you can use JSON cleaner, merge data, combine filter data, and all of that. So for all the functions that you write in the code, they have created a component, a widget for you to use is the drag and drop. And then you have these tools. Okay, this will be used when we do the agentic AI. So when we do AI agents, so you have to give some tools to the agents. So those tools can be, Bing Search API, Calculator, DuckDuckGo Search, Google Search, Python REPL, Retriever tool. So all of these are the pre-built tools that are available off the shelf that you can use, or you can create your own tool function and then create a tool and then use it in the AI, in the agents as a tool for the agentic AI. All right. So that is all I wanted to show you today. I didn't want to show much again. So I just want to introduce you to the couple of low code or no code platforms, and then we will be exploring these in the next 2-3 days to build the RAG and the agentic AI. Okay. Any questions? So I'm not sure basically how once you build here, you will have a platform within the data stacks to actually expose it as an API. Okay. So authentication. So you can just create it as a chatbot again, and then expose it as an API. So users can use that, connect to that API, and then ask questions, and then your entire agent will run. And then you can actually put this entire application into production, deploy it, and then expose it as an API. All right. Any other questions? So for you, I think today you have been introduced to two of the no-code, low-code platforms. The assignment or homework for you is to get access to these platforms by tomorrow. Create an AWS account and at least navigate until the Amazon Bedrock. Okay. And also create an account on the data stacks. Just go here and type, say, Langflow data stacks, and then Astra data stacks, Langflow, or whatever. So then you can actually get started with this Langflow and create an account here first. Okay, once you create an account, you can go to select Langflow and then come here. So Astra DB is also their cloud native storage, and Langflow is their low code app development. Okay. All right. So that is, as I said, we will wrap up early today. But you have all of these things. We did RAG this. I will share. Probably you already have access to this folder. If not, ping in the group. Ishrat will take care of giving access to your email IDs to this folder. You will have all of these collab notebooks, Python notebooks. You can look at RAG with FireDB and try to check and practice these things. And the two other things is create your accounts in the AWS or Bedrock and in the DataStax Langflow. That is for today. Okay. Yeah.
And the main difference, what is the difference between these components, Astra creating flow in data stacks and Amazon AWS? Is that
Are you able to
going to
see my screen?
Yeah.
Okay. I thought for a minute. Oh, where are my floating controls? Time to zoom. Okay. Okay. Sorry, Nabigar. I was distracted. I was looking at something else. Can you come again?
So which the environments, right? We work on the AWS side, on the Amazon side, and also you shown up Astra DB, right? What
DataStax.
exactly the similarities or differences when to choose Amazon AWS for creating such components and then data stacks like?
See, there is absolutely, I mean,
Mhm.
it's the same question, right? So we don't have a one particular answer. I cannot say, hey, Langflow is better than AWS or LangChain is better than Bedrock, right? Each of them are, see, let's say we have like a 1,000, close to more than 500 plus models, okay, LLM models. What do you think? How do you choose a model? Which one is better? Now we got DeepSeek. So whichever is popular and latest is all you hear about. You hear about DeepSeek. Then the moment you talk about GenAI or you meant to talk about LLM model, first thing that comes to mind is ChatGPT. Because just like a search engine, when you say Google is synonymous with search engine, though there are like Bing, it's been there for decades, as long as or even before Google. There are other some search engines that are available, but still Google is the only thing that comes to mind. Similarly, ChatGPT is the first thing that comes to mind when you talk about LLM model. So then ChatGPT is there, ChatGPT 3 is there, 4 is there, Anthropic, Claude, Grok, Cohere, Mistral. then Meta Llama. So many models are there. So what are different? So they are all same. So they are at the basic, they are, as you say, number of parameters they are trained in. This is, 70 billion, 7 billion, 70 billion parameters they are trained in. So there are some features when you look at evaluating an LLM model. Again, I think we discussed this earlier also. It depends on the use case, right? Let's say, as I said last time also, so let's say I am a cancer research organization. I have no utility for a chat GPT model in general sense. I have, but chat GPT can answer most of the things and has information most of the things which I don't need, which is just like it's there, but I don't need it. Versus there is a smaller model which is trained on smaller data, but specific to cancer research. Cancer, information from the patients, their medical history, their treatment, and how they, various stages, how they performed at each stage, how they responded to each drug, clinical trials, which drug is performing, to which state. So all of these things only, and what are the latest advancement in terms of the cancer drugs or the research journals. So let's say this model is only trained on this, and it's a smaller model. Now, what do you think I should choose? Should I choose ChatGPT because it is famous? Or should I choose the smaller model because it is domain specific and I only need that? So based on my use case, I will obviously go for the smaller model. Plus, it comes at a lower price, maybe. Or maybe it is expensive because it is domain specific and it has more utility for only that specific. It might be more expensive, but seeing the utility for me, my use case, I would still have to, I will be inclined to use that. First thing, right? And second, you talk about Bedrock, right? So if I have the model, so that model I can use anywhere. I can write a Python script and use that model in my Python script. If it is on Hugging Face, I can write an API and pull it from Hugging Face. There are two things that come into play here. When I'm using it on Hugging Face, how is my data transfer happening, right? So is my data leaving my network? Obviously, if I send an API call to a model that is served, right? So you are sending the data, the questions about whatever in a API. Okay, so there is some security issue. Maybe you don't want to do that. So do you want to have it within your network on-prem? Second thing, maybe my organization already has AWS. I'm already using AWS. So it will be easier for me to just integrate the model, choose that model on the Bedrock so that all my data, if I'm already using AWS, for example, it will be either in S3 or somewhere in Redshift or somewhere within the AWS. So it will be easier for me to connect and get that data to the model. And I can use all the existing security, privacy, the IAM roles, the RBACs, all of that is already in place. So I can reuse all of that. So my obvious choice would be to use Bedrock instead of again going for DataStax Langflow and integrating it with Bedrock and giving the data from S3 to all of that. So that will be a little more complex and expensive maybe, or maybe it is cheaper than using Amazon services because it's charged on the service of use. So there are so many these kind of parameters that you need to look at when you evaluate. So it's not a straight shot answer, hey, go use AWS, or hey, I use Langflow. It looks easier. It depends on use case to use case. If I am a very small company, I just want to have some chatbot. I don't need any of this. I just write a Python script and run it on the server. That's it. I use an open source model, right? So build a RAG application. If I have all, I dump in a folder my files. Just like you say, customer service. Just we did one use case using the washer manual and other thing, right? So why would he need so if he's a small organization, small company, why cannot afford to have a hyperscalers and cloud platforms? Maybe it's an overkill for his size. So it's a basically use case to use case, but these are all the parameters that you need to keep in mind to evaluate what I need.
Okay.
Okay. Does that answer?
Yeah.
Okay. Yeah, I know. I mean, so that's what I've been seeing. So, anything else? Are we all good for today?